one we call a scalene triangle. Now, let's look at all the properties that are associated with this. Remember, if you don't think you can write fast enough, okay, just take a screenshot. If you're on a laptop, press PRTSC. If your laptop doesn't have that button, I can't help you. I don't know how to do it, guys. It took me 2 months to learn that you have to, or you actually have to press Windows first. See, do you see what I mean? So I don't know. If it doesn't work, then I don't know. So the Windows button plus PRTSC. So a scalene triangle has sides that are all different lengths. Okay, so if we look at our examples at the bottom, okay, so if this length is 7, then this will maybe be 4, and this will be like 2. So all the sides are different lengths. And not only are the sides different lengths, the angles are different lengths. So this angle over here, well, it's yellow already, but you get the point, will be different from that angle over there, which will be different from the third angle in your triangle. If your triangle meets all of these properties, then it would be a scalene triangle. Okay, so this picture below is a nice illustration of what a scalene triangle looks like. Nothing, nope. Sentence was like, peace, I'm out. None of the angles are equal. None of the sides are equal. Okay, nothing is the same. That was definitely not intentional, but that's a great way to remember it, okay? Scalene triangle, everything is different sizes, okay? Now, we move on to an isosceles triangle. And I know spelling for this triangle is a little bit lit, okay? I know spelling is a little bit lit for this one. Welcome to all the new people. You want me to zoom in a bit? Okay, that's as much as I can zoom in without taking up all my space. There we go. Now, isosceles, please pay attention to the spelling. I know spelling shakes when it comes to this triangle. That's the only reason why I'm highlighting it, okay? I'm not being shady. So, isosceles, or actually isosceles triangle, it has two sides that are equal, shown by these small lines over here, guys. Do you see these lines? Those lines are telling you that those two sides are equal, okay? And additionally, if those two sides are equal, then the angles will be equal. Okay, so the angles that are opposite the equal sides will also be equal. So look here, that's one equal side, opposite. That's another equal side, opposite. Those angles will be equal. So the third angle will not be the same size, but the two sides and two angles are equal. Yes, if you want to remember how to spell it, you can say isosceles. Okay, Oratile, do you have a question about these triangles?
Yes, ma'am. Ma'am, this triangle, the isosceles, ma'am, is when we draw it, ma'am, and we put like that, the parallel side, ma'am, are we wrong?
Parallel. Where would you put
For
parallel?
the
There,
the blue
on the
ones,
side.
ma'am. Yes, ma'am.
No, that would be wrong. Okay, because parallel signs means the lines are parallel and the lines cannot be parallel. Okay.
Yes, ma'am.
Remember,
Thank
parallel
you, ma'am.
lines never meet or touch, but in a triangle, they have to meet or touch in order to close the shape. Do you agree?
Yes, ma'am. Thank you, ma'am.
You're welcome. Okay. So our third type of triangle is an equilateral triangle. And the biggest clue in this triangle is the equi, which should remind you of equal. Okay, so all the sides and all the angles are equal. Yes, Chi-Chi.
Hello, ma'am.
Hello.
Ma'am, I just wanted to say that we were learning about the equilateral and all the other shapes of the geometry thing. So an equilateral, how I'm understanding it is that it equals it, like all the sides are the same, and it equals to is 180. Yeah, it's 180.
Okay, all triangles are equal to 180. Okay,
Yes,
but
ma'am. Yeah.
Chichi, if they are all 180, then one of them is how much?
Ma'am?
If all the angles are 180, then one of them has to be how much? So on the sketch, look.
45, ma'am.
No, on the sketch. If all,
60
remember there are
degrees.
3 angles in a triangle, right?
Yes, ma'am.
And if they all have to add up to 180, but they are all equal, then all of them have to be how much?
60 degrees.
There we go. Because 60 plus another 60 plus another 60 will give you 180.
180.
Nice. Okay. Sive, hello. You may unmute.
Hello, ma'am.
Hello.
Oh, yeah. So, ma'am, at school, ma'am, Mr. Nguyenyas told us about the statements. I don't know about the statements.
Yes. Yes, Sive, we're getting to that. Okay. That is a good thing to bring up. Okay. So, guys, what Sive is talking about is our reasons. So remember, when we were doing geometry, just a previous geometry of straight lines, that is, when we were doing that chapter, we always had reasons for what we were saying, right? So you would have a statement. That's just what you are saying. And then we'd have a reason. Right. So in an equilateral triangle, let's say I didn't give you the third angle. Okay, let's say I only gave you 2 angles. And this one was blacked out or blurred out. And I ask you, what is the size of this angle? And you know that this is an equilateral triangle, right? Then you can say X is 60 degrees. And your reason is because it is an equilateral triangle. Now that will tell me immediately that all the angles and all the sides are equal. So then I know it has to be 60. Okay, so remember I said we are going to have another reasons sheet when we're done with shapes, right? I gave you a first one when we were doing the geometry of straight lines. Now we're going to need another one when we're doing shapes because they all have their own properties, okay? So keep that in mind and keep coming to the lessons. You will get it, guys. So I think we all know all this says is it is equiangular. Equiangular means what? Equi means equal. Angular is talking about angles. So this angle has the same size. This triangle, excuse me, all the angles have to be the same size. Look at our example here. If they have to add up to 180, that means they are all 60. Now, if this side on the side here is 7 centimeters, let's call it 7 centimeters, how much will the side be over here? What do you guys think? If side A is, okay, maybe I should name it ABC. So if AC is 7 centimeters, then AB will be 7 centimeters. Okay, so if this was a question, then you can say, therefore, AB is 7 centimeters. And your reason? Equilateral triangle. Okay. I hope Sive understands what we mean here, but I'll give you a nice sheet that gives you all of the reasons. Okay. Now, we have been categorizing triangles using mainly sides, right? So look here, equilateral triangle, equal sides. Isosceles triangle, 2 equal sides. Scalene triangle, no equal sides. But now we're going to talk about the angles. What is an acute triangle, right? What is an acute angle? Let's start there. Does anyone remember what an acute angle is? Yes, or Adile?
Ma'am, an acute angle is an angle smaller than a right angle, ma'am, and it is equal to 45 degrees.
It's not equal to 45, but it is less than
Yes.
90
Yes.
degrees. Thank you, Radile. So guys, therefore, if I have an acute triangle, that means the interior angles have to be acute. So the angles that are inside the triangle, look here. This angle is inside the triangle, inside the triangle. What does the symbol mean? Just so we don't confuse anyone. What does the symbol mean? Because all of those are saying that symbol and a 90 degrees. No. Okay, I see why you would think it means that, but no. There we go. Okay, Tando says less or greater. Which one, Tando? Which one? Thank you, Zianda. That means this angle is less than 90 degrees. Okay. No, guys, it means less than. It's not the angle one, it's the less than one. Okay. I understand the confusion. Okay, I saw your quiz. It's okay, I get it. It's the less than symbol. It's the less than 90 degrees. So if I say less than 90 degrees, give me anything that this angle could be. What could it possibly be if it is less than 90? Thank you very much, Kamogelo. It could be 54 degrees, okay? And the other one could be 69 degrees. And for the third one, we can't guess, but you guys get my point, okay? So an acute triangle means that all my angles inside the triangle have to be less than 90 degrees. Then it will be classified as an acute triangle, okay? Now we are on an obtuse triangle. What is an obtuse angle? Let's see if we remember what an obtuse angle is. Ratile is on fire today. Oh, Ntando, let's hear a different voice. Ntando?
Hello, ma'am.
Hello.
How are you, ma'am?
I'm well, and you?
I'm good, ma'am. The answer, ma'am, here is gonna be greater than 90 degrees.
That is correct, Ntando.
Yes, ma'am.
Obtuse means greater than 90 degrees. So an obtuse triangle means that one of the angles is greater than 90 degrees. Okay, it can't be more than one. So only one of them is greater than 90 degrees. And if one of them is greater than 90, then the rest have to be what? Acute angles. Okay, these are properties that are useful to know. So only one of them have to be 90 degrees. So if you look at my triangle here, now that is facing the other way from the previous one. It is that way. Okay, so that would be greater than 90 degrees. That would be an obtuse triangle. And now we have the last one. We have the last one. And that would be my right triangle or my right angled triangle. Okay. Now, what is a right angle? Thank you very much. Kamaholo answered me before I even asked. Thank you, Malibongwe. Where's everybody else? Yes, Tando. There's 107 of you guys in here. I'm expecting a lot more participation. There we go. Kohlali. Tiamo. Lesotho's like, look, I'm going to send it anyway. Like 50 people sent it, but I'm going to do it anyway. And she put an emoji there like, you don't share answers. Ay. See, I'm Tando's busy writing the right things there, but he's like, yeah, you guys will suffer. I'm not going to share my answers with you guys. It's fine. Okay, there we go. Equal to 90. So then one of them has to be equal to 90. Okay. So if this is triangle ABC, we have one angle equal to exactly 90 degrees. Okay, I am hoping that we all understand. Oh, they said something important here that I almost missed. The hypotenuse. Which one is the hypotenuse, guys? We're going to need that in the next 2 lessons. Yes, in the 3rd lesson from today. AC, it is opposite the right angle. And B, it is the longest side of my triangle. Okay, so in a right angle triangle, we have, where is it? It is the longest side, and that is a hypotenuse, and it will be opposite the right angle triangle. So side AC will be, Kamra is like stealing answers. Yes, you guys must steal each other's answers. If one person is wrong, I know something is wrong because you guys are not helping each other. So this then will be your hypotenuse. Okay. Yes, Pythagoras is on its way, my dear. You could sense it. I can sense it. It's on the way. Okay, now we are going to do an activity. So you guys must tell me what type of triangle is this true for. So for example, if two sides of the triangle are equal, then it will be true for an isosceles triangle. Ugh, that looks terrible. Can I just say isos? Getting us ready for our reasons. Also, my handwriting is not cooperating, honestly. All right, guys, this is not a true or false. Okay, you need to tell me which triangle does this apply to. That's what it's asking. It's not true or false. Okay. Thank you. See, Tando? Tando is cooperating. Okay, number B says, one angle of the triangle is obtuse. What type of triangle is that? It's actually in the name. Isos. Isos. What is it? Thank you very much, Wadey. It is true for an obtuse triangle. Okay, two angles of the triangle are equal. What is that true for? What type of triangle is that true for? Kamukhelo says equilateral, I'm assuming. Yay, it is an isos. Isos triangle. Okay, where are we? Number D says all three angles of the triangle are equal to 60 degrees. Thank you, Mikhail. I keep saying your name wrong. All right, but I keep getting confused because I'm thinking of another Mikhail from where I teach, but it's fine. Yes, that is an equilateral triangle. Okay. Now we are on E. Okay, we haven't done E, but the size of an exterior angle is equal to the sum of the opposite interior angles. Now I'm going to tell you now that counts for all triangles, okay? The sum of the exterior angle, we still haven't done it. Don't panic. This is true for all triangles. Everyone who has done triangles before, help me here. Okay, I know you guys have done them before. Chichi is awfully quiet. Where did Chichi go? Yes, Kamkhel, it's all of them. If the longest side of the triangle is opposite the biggest angle, thank you very much, Mikhail. See, I change it every time I say it. It's Mikhail, there we go. This is for a right angle triangle. Right angle triangle. See, okay, I see why you guys thought this is an angle symbol. Okay, the sum of the two shorter sides of the triangle is bigger than the length of the longest side. The sum of the two shorter sides, the sum, when you add the two shorter sides, okay, the answer will be bigger than the length of the longest side. So what type of triangle would that be true for? Okay, we're saying scalene. Kamogelo says sauce. Okay, let's see a triangle. Oh, that was supposed to be a triangle. Forgive me. Forgive me, people. Let's insert a shape. Oh, Malibongo also says equilateral. Yes, that would be correct. That would be correct. Okay. We have a triangle. Okay. We have a triangle. But it's like question mark. What's going on, guys? That is true for actually all triangles now that I look at it. Now that I think about it. So let's say this is my triangle and it's an isosceles. So this will be 4, this will be 4, and this will be 7. Right? So it says the sum of the shorter sides. So 4 plus 4 will definitely be greater than 7. Leave me alone. You guys are harassing me to draw. That was so shady. I can't believe it. Wow. As for mem draw, I don't want to draw. Okay. Leave me alone. Can you see, guys? Isn't that true for all triangles? Did you see that? Let's try another one. Okay, let me not erase my work, my beautiful work. Let's try another one. Let's try scalene triangle. So if we have 4 and 2 and 8. Oh, is it true for a scalene triangle? Ho ho. So we have established that it is true for isos. Is it true for a scalene triangle? Look at the example that I've put down now. No, but this is a really tricky question, guys. I don't know how you can establish that unless you know the exact sides. So far we've established it. I'm just going to leave it for isosceles triangle and equilateral triangle. Of course, it's true for an equilateral triangle. Okay, leave me alone, Kamukelo. Okay, H says the square of the length of one side is equal to the sum of the squares of the other side. Someone brought this up while we were working just now. What is it called? What is it called when you do that, guys? One side squared plus one side squared equals the longest side squared. What did we call it again? Someone brought it up. Who knows what that is? Thank you, Pythagoras. And when do we use Pythagoras, Mikhail? When do we use Pythagoras, people? With a right triangle. Isn't that beautiful? Beautifully answered. Thank you, Butlale. Yes. And now it's just getting ridiculous. The square of the length of one side is bigger than the sum of the squares of the other side. Yeah, we wouldn't know. Let's just leave it alone. Yes, Butle, I see your DM. That's correct. I is just being ridiculous right now. Okay. And then let's go to J. Sum of interior angles of a triangle is 180. When does that? Thank you very much. All triangles. Okay. Now, we're going to look at 3 triangles, and now I have to zoom out. Okay. Whoever couldn't see, now it's time for me to zoom out. I'm sorry. Please try zooming in on your screen so we can see our 3 triangles. There we go. There we go. So you guys are going to have to tell me. Number 1 says triangle something is an acute isosceles triangle because that and that. So we want 2 reasons for what you are saying. Okay, so you're going to classify these triangles and you're going to give me 2 reasons why you are classifying them the way it is. Okay, Now, let's start with triangle. So this is how we name them, guys, okay? You go along the lines. So then the first one will be triangle JKL. And Oliver has already answered me. Oliver says it is an isosceles, but now, Oliver, we have an acute isosceles, a right angled isosceles, and an obtuse isosceles. So where does JKL fall, guys? Is it an acute isosceles, a right angled isosceles, or an obtuse isosceles? Luguwe. Yes, sir. Yes, Oliver. Yes, Kamuhelo. Yes, Sianda. So number one is triangle JKL is an acute isosceles. What are my two reasons? So JKL is number one. Now you guys need to give me two reasons why you say it's an isosceles. It's an acute isosceles triangle. You have to make assumptions, Mikhail. See, like Leseho. So the angles are less than 90 degrees. Oluhle, please raise your hand, my darling, so I can help you. There we go. Hello, Oluhle.
Hi, ma'am.
Where did I lose you?
I'm not quite understanding the work. I mean, I did get the work we were doing before, all the triangles and the activity we did above, but then I'm kind of lost.
Okay, Oluhle. So generally in maths now, when we use the same type of arrows, it means the angles are the same. Okay. Well, the same size. Let me say the same size. So if you look here, Oluhle, do you see this little dude over here and this one over here? They look exactly the same.
Yes.
So then we can assume that if these two angles are the same, then what type of triangle does this make it? If it has two equal angles.
It makes it an isosceles.
Wonderful. So now we've established that it's an isosceles. Are you with me so far?
Yeah.
But now all three are isosceles. We have a problem. Do you see?
Yes.
Okay, now you're going to look. Is this a right-angled isosceles? Do you see a right angle in JKL?
Right
JKL,
angle.
this one. You see a right angle?
No, I do not.
No. So it's definitely not a right-angled isosceles. Do you agree?
Yes.
There we go. Now let's move on. Obtuse. An obtuse angle is greater than 90, so it's a wide angle. Do you agree?
Yeah.
Do any of these angles in JKL look like they are wide and greater than 90 degrees?
No, they don't.
No. So it's definitely not an obtuse isosceles, right?
Yeah.
But don't all these angles look less than 90 degrees? They look quite small, right?
Yes.
So then we can assume that JKL is an acute isosceles. So we are combining properties, do you see?
Yes.
So we're saying, therefore, JKL is an acute isosceles triangle. And then with my two reasons, so first reason is going to be, well, it has two equal angles. That's why I said it was an isosceles. And my second reason will be, all the angles are less than 90. So it has to be an acute isosceles. Do you see how we're doing it?
Yes, ma'am.
There we go. Are you feeling better?
Thank you, ma'am.
You're welcome. Okay, guys, I hope you guys are feeling better. So then I already gave you the two reasons for the first one. Okay. So then the first one, JKL, has to be acute isosceles. And my first reason is all angles are less than 90 degrees. And it has two equal angles. Okay, I saw someone answer for MNO. I saw someone answer for MNO. Yes, Kamogelo, someone wanted to take a screenshot. There you go. Please do so in a few seconds. Okay. And Zianda. So we've already established that these are all isosceles triangles, right? They have two equal angles. So MNO has to be a what? MNO has to be a, and even NOM is fine, Taylor, as long as you're following an order, okay? You can't skip around. You can't say no. In a triangle, it actually doesn't matter, now that I think about it. There we go. It's right angled because, guys, we see a 90-degree angle over there. And we see two equal angles. So A, it's an isosceles, and B, it's a right angled isosceles. Nice. So then MNO or MON is then a right angle isosceles because we have two equal angles. And we have a 90-degree angle. Okay, now the last one. Is this an obtuse isosceles? Yes, it is. What are my two reasons, guys? What are my two reasons? So I'm going to say PQR is a obtuse isosceles. First, we know we have two equal angles. But also what? I think I'm going to start writing with the cookie because I can barely see what's going on here. And also there is an angle that is greater than 90. So we have an angle greater than 90 degrees. Beautiful, guys. So you see these properties can overlap. These properties can overlap. Nice. Now let me have a check, and I haven't checked in this whole lesson. That is terrible. Thumbs up, thumbs down. How do we feel about types of triangles? Okay, I see thumbs up. Guys, you can either, the new people, you can do it in the chat or in reactions. Okay, so you can press reactions, thumbs up, or in the chat, you can just send a thumbs up. Wonderful. I see your thumbs up. If you don't understand, put a thumbs down so we can explain. Yes, Lwandle? You may unmute.
Ma'am, sorry, I sent that by mistake.
Oh, okay, no problem. Okay, Chi, I see you have a thumbs down. Do you have a question? Okay, before I kill you guys, I promise you I'll take you to a brain break first. I looked at the question and I'm like, oh, maybe we should first have a break. And then, yeah, okay, Chichi says my Wi-Fi. Okay, Chichi, you'll catch on, okay? Let's go. We are coming back to the sun. I don't forget. So since we're doing triangles, I thought it would be fitting to have a brain break that has to do with triangles. Now, you guys have to tell me how many triangles you find in this shape. Don't cheat me. Don't tell me about diamonds and arrowheads and a semi-triangle. Hey, me, I'm seeing 5. So everyone is saying 5. Guys, did you count those? Peer pressure getting to you? Now we have 6. Mikhail says 8. Umata says 7. Malibong is 6. Uleboheng 6. Siamo is crying and saying 7. Oh. Hectic. Okay, we have to count. We have to actually count, guys. Let's see. Let's see. Okay, how many triangles do we see? Okay, so it's these 5 that's outside, right? So it's AIJ. We have AIJ, and then BHI, And then CHF. These are all the ones that are outside, right? DFG and JGE. Okay, now we have to find other ones. Oh, there's one there by, let me whip out the highlighters for my own eyes. There's one here by AHD. Okay. Oratile is gonna help me with the rest of them because my eyes just tapped out. Yes, Oratile.
Ma'am, also BFE, ma'am.
Let's see. BFE. Yes, that would be a triangle. BFE.
Ma'am, ADH.
ADH. I think that's what I was meant to write in the previous one because AHG is
Yeah.
definitely not a triangle.
Sorry, I wanted to correct you, but you were a bit busy.
Because I'm like, wait, what? So it's actually ADH. There we go. Wonderful. Okay. And then, is that all? 1, 2, 3, 4, 5, 6, 7. There's people who are saying 8. So people who said 8, tell me where the 8th one is.
ACG.
ACG. Or GC. AGC. Is that all, guys? I can't see any other triangles besides that. Huh? That is 8 triangles. CIE. CIE. Is that not a triangle? That is a triangle, isn't it? Someone, am I seeing stuff? Please help me here.
No, that is a triangle.
So we have another one.
I'm so confused. Where did that come from? Wow.
So it's not 8 triangles, guys. This is abomination. I didn't write it, did I? Nope, I didn't. Okay, whoever said CIE, we didn't see it. Okay, now we have a whole flurry of new triangles, guys. Okay, woo! I saw JBD. Let's see, J. Where's B? B. Oh. Ho 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 ho. Simone, I think we're not gonna run out of triangles here. Someone said DBE. Someone really likes maths. Let's see. D. Where's D? D. B. E. No, that's not a triangle because it has to close there. Okay, is that all of them now? HAD. Had. That's another one, guys. How are you seeing these triangles? Now my mind is blown. How many triangles are we actually supposed to find here?
Okay, no, but HAD,
Oh
we
no,
have
I already wrote
ADH.
that one. Yes, I already wrote.
I was gonna say these triangles are coming out of nowhere.
I'm trying to let's see if there's no duplication, guys. Let's be serious about life here. Because wow, I was very confident in the ones I already had.
Yeah, I think we're done now. I think this is it.
Okay, so let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. BEF, we have, guys, we have BFE. I feel like we duplicated somewhere. Okay, I'm over it. I found 10. I'm not gonna sleep tonight, Simone, and this is my own brain break. I'm not sleeping tonight. Woo! Okay, that was a lot.
Hey, tell yourself we found all. We found all. It's okay. It's done.
I was gonna have another one, but there's no time. Let's go up. If you guys can solve this, we'll have our second brain break. How's that? Yes, Chi Chi. Hi, Chi Chi.
Yes, ma'am.
Hello.
Ma'am, I was going to say something. I was going to ask a question about the brain break that you just had.
Okay, what about it?
I was actually very confused about where everyone was finding all the angles because I literally don't see any triangles. But until like you started highlighting the triangles, and I'm like, oh, now I see them. I'm like, where's everyone getting this from? I literally don't see anything.
Samesies, Chi Chi, samesies. Let's hear if Mikhail can do this for us or help me, and then we're gonna have a second brain break. Yes, Mikhail.
Ma'am, I see like an N. So would that mean that K2 is equal to N2?
K2 is equal to?
N2, because the lines are parallel and it looks like an N. So they're alternating
How much is
angles.
it? What's the degrees for K2? It's actually L2.
Yeah,
We
I'm sorry.
fell into a bad trap. So L2 is how much?
53.
Okay. Which N are you seeing? Let's do that. I'm seeing this one. Can you see it?
Yes, ma'am.
So which angles are actually equal? It is the L2 and the 60. Can you see?
Yes, ma'am.
So L2 is 60 degrees. Do you know my reason? Nope. We're looking for the triangle LMN. Okay, let me highlight it. The question is, what type of triangle is this? You must use other methods to find the angles in the triangle, and then tell me what type of triangle this is. Lucanio is dying to say the right thing, and I get what you're saying, Lucanio. It's alternate angles. And my parallel lines are KL is parallel to MN. Alternate, guys, not alternative. Alternate. Okay, so it says KL is parallel to MN. Wonderful. So now we know that L2 is 60. How are we going to use that to find N1? Does anybody know? Okay, Oral Dean use a different method. Oral Dean use a different method. We haven't done that yet, Oral Dean, but it's good that you know it. Yes, Siam Tanda.
Hello, ma'am.
Mm-hmm.
Ma'am, isn't number 1 is equals to n?
Number 1.
Yeah.
Yeah, that's what we're finding.
Also, we're looking for n now.
Well, it's N1. So this is N2. So we're looking for the angle N1.
Oh, can I try it, ma'am?
Go ahead, let's hear.
Okay, so we're going to say n1 plus 60 degrees plus 53 degrees equals to 180.
My reason.
Sum of angles in a triangle.
Oh, okay. What other reason could we have used? Can you see it? Look at your parallel lines. Ooh. Do you see the U?
Oh, yes, ma'am.
So we could have also used co-interior angles because KL is parallel to MN.
Yeah.
Wonderful. Now let's finish it off.
Okay, so we're going to say N1 is equals to it's equals to 113.
113. Are
I
you
mean,
sure?
Ma'am, it's supposed to be N1 plus 113. Sorry.
Oh, plus 113. I was gonna be like, what? Nope. Okay,
Sorry, my bad.
113 equals 180. Okay.
Okay, so then ma'am, we're going to take the 113 to the other side, which will equal to 67 degrees. N1 is
Therefore,
equal to 67 degrees.
67 degrees. So then, guys, back to my question. What type of triangle do we have here? What type of triangle do we have here? Firstly, we need to talk about the angles, and then we need to talk about the sides. Oh, what does equilateral mean, Malibongwe? Thank you, Omatla. So we have a scale. All angles are different. But what other property do we have? It's a scalene. What? Is it an obtuse triangle? Is it a right angle triangle? So you need to tell me something about the sides. There we go. So we have an acute scalene triangle. And that is the end of our lesson.